following sessions, I will introduce the basic tools for making decisions and to structure our programs, the control statements and the function definition. But before that, we need to know something more about list and other compound data types. We are going back to something simple, variables, but a little more in depth. Think about it. Variables store one bit of information, like a number or a text string. But what if you need to store a long list of information which doesn't change over time? Say, for example, the names of the months of the year, or maybe a long list of information, a list that changes over time. Say, for example, the temperatures registered by a weather station. What about a phone book? For that, you need to do a bit of referencing. You will have a list of names and attach it to each of those names a phone number. How will you do that? For these three problems, Python uses three different solutions: list, tuples, and dictionaries that are compound types. Compound data types are used to group together other values. Lists are what they seem, a list of values. Each one of them is numbered starting from 0. The first one is number 0, the second one, the third 2, etc. You can remove and modify values from the list and add new values to the end. Tuples are just like lists, but you can change their values. The values that you give it first up are the values that you are stuck with for the rest of the program. Dictionaries are similar to what their name suggests, a dictionary. In a dictionary you have an index of words, and for each of them a definition. In Python, the word is called key, and the definition a value. Let's start with the first one. A list can be written as a list of comma-separated values, items, between square brackets. List might contain items of different types, but usually the items all have the same type. For example, the list of prime numbers, or the same but in a more heterogeneous way. Internally, the list is an item box that stores an ordered list of references to other objects. Therefore, it is a sequence of Python identifiers. Those references could point to anything in the memory of Python. Like strings and all other built-in sequence type, lists can be indexed or sliced. Indexing returns the item, while slicing returns a new list. All slice operations return a new list containing the requested elements. This means that the following slice returns a new copy of the list. Lists also support operations like concatenation. Let us make an aside before continuing on list explanation. We have seen that variables in Python are like boxes with the labels stuck to them. Each box has two important characteristics: the type of its content and a unique reference number. Well, there is one thing more. Boxes could be mutable or immutable. An immutable type is something that cannot be modified. Let's go back to the list and see why this is so important. I'm going to create a list of letters and a text string. Lists are of mutable type, that is, the content of the list could be modified, while strings and numeric values are immutable. Thus, it is not possible to modify its content. Unlike strings, which are immutable, lists are a mutable type. So, if I try to modify one letter of the string, Python will throw an error exception, as you can see in the example. You can also add new items at the end of the list by using the append method. We will see more about methods later. So we have the list A, B, C, D, E, and we are going to add the letter F. A segment to a slice is also possible, and this can even change the size of the list or clear it entirely. For example, we can replace some values. And now we are going to remove them. We can easily clear the list by replacing all the elements with an empty list. There is a built-in function, the function len, that applies to any sequence to retrieve the number of items contained. It is possible, of course, to nest lists, that is, to create lists containing other lists. For example, we have the list A with the letters A, B, C, and the list N with the numbers 1, 2, 3. So we are going to create a list with the list A and the list N. Okay, let's see the next compound type. Tuples are pretty easy to make. A tuple can be written as a list of comma-separated values, items, between parentheses. You may have spaces after the commas if you feel it necessary. It doesn't really matter. Python then organizes those values in a handy numbered index, starting from 0, in the order that you entered them in. It will be organized like this. Tuples are immutable. It is not possible to append or remove items or modify any of the tuple's references. Nevertheless, here is something important. If the tuple contains a mutable object, it is possible to modify the object, not the tuple's items reference, but the object pointed by the reference. For example, we are going to create a tuple with a list included, A, and the tuple, V. The element 0 of the tuple is a list. There is no problem in modifying that list. We assign 20 to the third element of the list pointed by the first element of the tuple. So if we print A and B, notice how the original list A has been modified. This is because tuples and lists store reference to items, not the items. So if the referred item is something mutable, we can modify it. But if we try to modify the second value of the tuple, Python will throw an error because we have tried to modify the data of an immutable object. Okay, let's see the last component type of this session, dictionaries. Remember, dictionaries have keys and values. In a phone book, you have people's names, then their numbers. So it is a good example to illustrate what a dictionary is in Python. When you initially create a dictionary, it is very much like making a tuple or list. Tuples have parentheses, lists have square brackets, and dictionaries have curly braces. As you can see, we have associated a number to a name. When we want to phone someone, we access the stored data through the name. That's the key. Obviously, the data is the phone number. In the following example, we are going to create a dictionary with 2 phone numbers in it. To access any element of the dictionary, we can use the key as an index. The program will then print John's number on screen. Notice how instead of identifying the value by a number, like in the list or tuples, we identify the value using another value, in this case, the person's name. Adding new numbers to the book is quite simple. If in an assignation the key is not present in the dictionary, a new entry is created for it. You delete entries in a dictionary just like in a list. Let's say you get upset with Anne, and you do never want to talk to her again, and therefore you don't need her number. Just like in a list, you will do this. Again, very easy. The del operator deletes any function, variable, or entry in a list or dictionary. If you want to know if a key is in a dictionary, you just can write that expression will be true if there is an entry for John and false otherwise. Remember that append function that we used with the list? Well, there are quite a few of those that can be used with dictionaries. Let's see an example. First, we are going to define the dictionary. It will have nothing in it this time. Add a couple of names to the dictionary. We are going to store the values of the letters of the Roman numbers, for Y, V, X, and L. The method keys returns a list of all the keys. You could use this function to put all the key names in a list. So now letters have the list of all the Roman keys. You can also get a list of all the values in a dictionary. You use the values function, and we are going to put it in a list too. You can sort list with the sort function. It will sort all values in a list alphabetically, numerically, etc. You cannot sort dictionaries because they are not in particular order. Well, and finally, you can find the number of entries with the len function again. As a summary, in this session, we have View, the compound type list, some of its methods and operations like slicing, Tuples, as a kind of list that are immutable, and Dictionaries, a very powerful and important tool in Python. But we also have explained some more about how things are stored in memory through the explanation of mutable and immutable objects. This is especially important for understanding how functions parameters work in Python, as we will see in the next session.